Welcome back. In previous video you understood how to write MapReduce program using old API and new API, and also you understood how to write a driver using tool runner. In this video you will be running about two concepts, combiner and then we'll see partitioner. First let us see what is a combiner and when to use it. So before we talk about combiner, let us see the problems with mappers. Generally the mappers produce large amounts of intermediate data. So let's assume that I have a file of 640 MB and I am writing a word count word count program. So how many mapper tasks will be there? 640 MB means how many blocks? 10 blocks, each of 64 MB. So 10 map tasks will be there, and each map task will be outputting lot of key value pairs. Now after all 10 mappers are done, reducer might be executing on some other slave machine. All the output of all the 10 mappers have to travel from network and go to the node on which reducer is running. So there will be a lot of network traffic, right? So the data that must be passed to reducer will be very huge if the output of mappers is heavy. This can result in a lot of network traffic, which will reduce the performance. So to increase the performance, what we can do is we can use a combiner. What is a combiner? Combiner is like a mini reducer. The code of combiner is similar to a reducer. You can use reducer class itself as a combiner. So what happens is, if you set a combiner to this job, the combiner will work on the output of a single mapper. So let me show you through a diagram first. Suppose if there are 10 mappers, this is one mapper, another mapper, another mapper, another mapper. Let's assume that this is emitting some 1000 key value pairs. This is emitting some 1000 key value pairs. 1000, 4000 key value pairs, assume. So all these 4000 key value pairs have to travel over the network and come to the node on which reducer is executing. So there is no concept of data locality for reducer. So there might be a lot of network traffic. Now what we can do is, suppose if the map is emitting various key value pairs, suppose assume that this is a word count program. There is a word called as Shiva. What the word count mapper will be doing? It will be emitting Shiva, 1, and in another line also, if there is Shiva, it will again emit Shiva, 1, and if there is another Shiva, again it will emit Shiva, 1. So for same key there are 3 entries, is it? And assume that in this mapper also there are entries for Shiva. The mapper is emitting Shiva, 1, and here also Shiva, 1. Like that the key value pairs are emitted by all the mappers. Now if I specify a reducer, if I specify a combiner, what the combiner will do is, combiner will combine all the keys which are having same values. That means the combiner will take all these keys, and as I told, combiner will act like a mini reducer. The code of combiner is nothing but reducer code only. So for these 3 key value pairs, it will emit only one key value pair, Shiva, 3. So these 3 key value pairs are combined together and made as one single key value pair. So that is a combiner. So combiner will aggregate all the keys, all the key value pairs who are having same keys, and will emit a single key value pair. So on this machine again there are two entries for key Shiva. So on this mapper again the combiner will run locally on this mapper output, and it will be Shiva comma 2. So in case if you are using combiner, how many entries will be going to reducer now? 2 entries. If you are not using combiner, how many entries will be going to reducer? According to this case, 5 entries. So if you are using combiner, the amount of network traffic can be reduced. So to summarize, combiner is also behaving like a reducer only. Okay, so we can call combiner as a mini reducer. Where will be the combiner executed? Who will execute the combiner? The map task. Map task only will execute the combiner once the mapper's output is done. Map task only will execute on the same node. Okay, so combiners will work on the data emitted by the mapper. Okay, now let me come to presentation. As I told you, combiner is like a mini reducer. It runs locally on single mapper's output. And output of combiner is sent to reducer. Input and output data types for combiner and reducer are identical. As I told you, we generally use reducer class as a combiner only, so they are equal, identical. So technically this is possible if the operation performed is cumulative, commutative and associative. Okay, so let us take an example. If I am computing a sum of values in reducer, if I am writing a sum reducer, from one mapper I am getting Shiva comma 1, Shiva comma 1, Shiva comma 1. The output of my first mapper is this one. Output of another mapper, let's say it is Shiva comma 1 and Shiva comma 1. So if I am using combiner, what will go to reducer? Combiner will combine and pass Shiva comma 3 from this map, and combiner will pass from here, it will pass Shiva comma 2, and when this goes to reducer, reducer will output Shiva comma 5, right? So there is no effect in the output if you are using combiner. But let's say I am calculating average in a reducer. So what happens if it is not sum? What will be the output of this? What will be the output of this average? Output of this will be Shiva comma 1, and output of this also will be Shiva comma 1, and when it goes to reducer, again the output will be Shiva comma 1. So in case of average also it is looking same. Okay, let us not take 1 1 1 as the values. Let's say here it is 10, this is 15. Let's assume the values emitted are 15 and 20, say 25. Okay, and here it is say 10 and that's it 40. Now let's say the first value also will be 15. Let's say this is 10 only. So what will be the average? 10 plus 15, 25, 25 plus 25, 50, 50 by 3. 50 by 3 will be the value here emitted by the combiner. Here what? Here it is 10 plus 40, 50 by 2, 25. So again the average of this will be 50 by 3 plus 25 by 2. That means it is a 16.6. That means it is 41.6 is equals to by 2 means 20.8. But if there is no combiner, what will be the output? If there is only reducer, what will be the output from the reducer? 10 plus 15, 25, 25 plus 25, 50, and here it is 50. 50, 100, 50 plus 50, 100. 100, and how many entries are there? 1, 2, 3, 4, 5, 5. So the value will be 20. So in this case of average, when you use combiner, the output will be 20.8. If you don't use combiner, then the output is 20. So the output is differing. So you can use combiner. Using combiner makes sense only in case of something like a sum. For average, computing average is not a commutative operation or associative operation. Okay. So we cannot use combiner. Using combiner does not make sense. We will get wrong outputs in case if you are using combiner for operations which are not commutative and associative. Okay. Okay, next. Hope you're all mathematics students and understand about commutative and associative. Commutative means what? A plus B is equals to B plus A. If that is the case, it is commutative. The reverse of operations, if it is same, then it is commutative. Associative means what? A plus B plus C is equals to A plus B plus C is commutative, right? Technically it is possible only if the operations whatever you are using are commutative. Generally addition is commutative, but average is not commutative. So you cannot use combiners for performing average kind of a thing. The output will be different. You have to be aware of this. So if you take an example of word count, for word count what? This will be the mapper. For each word, the mapper will emit the word comma 1, and the reducer will create sum of all the values. This is the pseudo code for word count program, is it? So if this is the 1, taking an example, the input to the mapper, if this is the 1, then output from mapper is what? The 1, cat 1, sat 1, like this is the output from the mapper. And intermediate data sent to reducer will be like this, is it? And final reducer output will be like this. In case if you don't use combiner, this is a 1. But if you use combiner, what happens? Combiner will combine the data from the mapper side only. So instead of sending the and 4 ones, the combiner will actually compute the sum on the mapper node itself, and the amount of data which is transferred is reduced. This is how combiners decrease the amount of network traffic required during shuffle and sort. Okay. So now you understood about combiner. How to specify a combiner? Very simple. On the configuration object. How to specify a combiner? On configuration object, you just have to set the combiner. And the combiner class is same as the reducer, as I said. You need not write a separate combiner class. Okay. The combiner also uses the same interface, reducer. Generally we will be using reducer itself as a combiner class. Okay. That's it. So very important, never put the code in combiner that alters the data from the mapper. Okay, because combiner may run more than once on the output from some mappers. So this is very important from examination point of view also, and anyway we will be discussing more on this point during my next video. Remember that combiners are not executed only once, not only once. On mapper, the combiner might be executed multiple times, maybe. Okay, it is not guaranteed that combiner will execute only once on the output of mapper. Combiner may run more than once on the output of some mappers. So you have to be very careful. Don't modify the data. Modifying the data could result in incorrect results. So your combiner should not modify the result. So keep this caution in mind whenever you are using combiner. Combiner can be used only the operations whatever you are performing in reducer are commutative and associative. Okay. Okay, next. So you have to implement a lab using combiner. So to use combiner, it is very simple to test on combiner. What you may have to do is go to any mapper. I am going to the first project. What we have to do is, in this mapper, if you want this program to use a reducer, very simple. On the configuration object, you have to set combiner class. Combiner class, see what is the argument? We should pass any class which is extending reducer. So I will pass some reducer dot class. So that's it to use a combiner. The output will be same. Only thing is, if you are using combiner, the performance may be increased. Okay. So try out by setting combiner, run the example and see the performance. Do this lab before going to the next topic. Now we will discuss on the next topic in the same video, partitioner. We have understood about partitioner in my earlier video. Basically, let me explain you again. Partitioner divides up the key space and partitioner controls which reducer each intermediate key and its associated value goes. So let me explain you through this diagram. See this diagram. Here is how a partitioner works. Suppose if there are 3 map tasks running, this mapper is emitting the key is 1, 3 and 0, 2, 4 and 3, 4, 0 and 1. Now for my MapReduce job, let's assume that I have configured 2 reducers. Which keys should go to which reducer? So by default, what happens is, before between map phase and reduce phase, as you know, there is one more phase called as shuffle and sort. Is it? Shuffle and sort. During shuffle and sort, during shuffle phase, basically forget about sort phase. During shuffle, what happens? Partitioner will be executed. By default, the default partitioner is hash partitioner. Okay. Hash partitioner, what it does by default is it will compute the hash of the key. So based on the hash of the key, modulus, I hope you know what is modulus. Hash of the key, it will be computed. It's a value, it's a number. Modulus, the number of reducers in this case is what? 2. So this will either return 0 or 1, right? So if the hash of the key modulus 2, why am I using 2? Because I have 2 reducers. If I am having 3 reducers, by modulus 3. So suppose if the number of reducers is 2, modulus 2 means the output of this will be either 0 or 1. So for a particular key, if this value is 0, it will go to first reducer. If hash of key modulus 2 is 1, it will go to second reducer, right? So hash partitioner will divide the key space based on hashing algorithm. Okay, That's how a hash partitioner internally works, and that is the default partitioner. See, if you want to write your own partitioner, or see how hash partitioner is implemented. This is the logic of hash partitioner. It implements an interface called as partitioner, where you have only one method called as get partition, where you will be passed with key and value, and also the number of reduced tasks. So here the logic, what it is doing is it is computing hash code of the key, it's ending it integer.max value, and modulus number of reduced tasks. The return value is int. So if the number of reduced tasks is 5, the probable values of this method, return value of this method, are from 1 to 4, either 0 or 0 to 4, 0, 1, 2, 3, 4. So based on the value written, if the value is 0, this key will go to first reducer. If the value is 1, this key value pair will go to second reducer, like that. Okay, so that's how a hash partitioner works. Now let us see a use case where we need to write a custom partitioner. Okay, let me just tell you a use case where a custom partitioner might be required. Let's assume that I am analyzing access logs of my website. So this is how a sample records in access log will look like. Each line will contain the IP and the date and time on which the request came, whether it is a get request or post request, the URL, status code, length of the response, etc. Now what I want to do is I want to find the total count of requests coming for an IP per month. So what I want is I want for this IP there might be some 2000 requests coming in January. So I want one file for January, one output file for January, where I'll get 10.223.157.186. How many requests came in January? 2000. And for February I want one more file where again for the same IP there might be some 3000 requests. So what I want is I want to find total number of requests coming for an IP for each month. So there are 12 months. So how many output files I want? 12 output files I want. One output file per month. So how many reducers? If you want 12 output files, you have to configure 12 reducers. So all the requests which contain January should go to reducer 1. All the requests for which the month is Feb should go to reducer 2. Like that, the key value pairs should go to one of the reducer among 12 reducers. So if all the requests for January are coming to the reducer 1, then on this reducer I can compute how many times this IP is coming as a key. I can compute the sum on this reducer and I can emit it. Okay, so that is my sample requirement. So what I will do is see my partitioner logic. I'll come back to show you a mapper. So first of all, see my mapper. So my mapper will be getting this line input like this, the input like this, where the first one is IP and this is the timestamp. Now in my mapper, what I am doing is I am splitting the lines by using separator space. And don't worry about this logic. What I am basically doing is I am emitting key as IP and the value is nothing but the month. Somehow the logic here is getting the value of this month, either Jan or Feb or March or APR, etc. So this is the key value pair emitted by my mapper. Then the output of mapper will come to partitioner during shuffle phase, right? So the partitioner, if you see, partitioner, my own partitioner, month partitioner is implementing partitioner, and what is the key and value pairs? Text comma text. Okay. So this configure method is the one where I can write some initialization code inside my partitioner. So whenever the partitioner is getting initialized, configure method will be called. What I am doing is I am preparing a map of month name and value 01. So I populated this hash map with months from Jan to December, and the get partition is getting the key value pairs. These are the key value pairs emitted by my mapper. What is the value for my mapper? It is a month name, right? So what I am doing is I am saying months dot get, the map dot get, what value will be, what month, either Jan or Feb, etc., right? So months dot get Jan will return what? 0. So that means this key value pair will go to first reducer. Okay. So like that I wrote my own partitioner, and reducer code will be same, some reducer, which is actually based on the key. It is emitting key. Key is what? IP from which the request came, and it is iterating through each value and summing up the count and writing the count of requests coming for that IP, right? Let me show you by running the example which I have already. Okay, so here is the project for custom partitioner. My solution is there. So whatever I have shown in my presentation, this is my partitioner where in the constructor itself I am creating a map and putting all key value pairs, and in get partition same logic. Okay. Then in my driver class, what I am doing, in my driver class, if you see, I am setting the number of reduced tasks as 12 because I want one file per month. So number of reduced tasks is 12, and the partitioner class is month partitioner dot class, and I am submitting it. So let me try to run. I don't want to hard code the number of reducers. I'll just try to use the tool command because anyway my class is implementing tool. Okay, so I'll go to command prompt. So I'll go to this project. What is the project name? 01 custom partitioner solution. 01 custom partitioner solution. I'll go to target classes. Okay, I'll create a jar CVF party.jar star. So it will create a jar with all the files. Okay, so I have the jar. So how to run it? Hadoop jar party.jar, and what is the driver class? in.co.way to learn dot log analyzer space, and what is, I need to pass the number of reduced tasks -d mapred dot reduce dot tasks equals to 12 space. What is the input folder? Do I have this access log file already? Yes, I think access log is already present in my slash user slash siva slash access log. This is a file, so I want to give that file as input, slash user slash siva slash access log. This is a file I want as input, and output I want as slash user slash siva slash partition out. This is a one I wanted as output folder. Let me run. So this should run and it should use the custom partitioner. Oh, what is the exception I got? What is it saying? Oh, access underscore log. Okay, the file name is access underscore log. Okay, so the total number of input paths to process is 1. Okay, only one file. So it will take some time. I'll pause my video and I'll show you the output once it is done. So the job is completed now. Let us check. How many reduced tasks? 14. Okay, so the number of reduced tasks is 14. Why? Maybe because of speculative execution. Let us see the output. There should be 12 files in user slash siva. There is party out. This is output folder. See, there are how many part files? 0 to 11, 12. So this file contains the count of requests for each IP in January. Reducer 0 is for January, right? Because in my code, if you see the partitioner, January is for 0. 0 means first reducer, part 0, right? So based on the partitioner, the output is going to corresponding reducer, and output of 12 reducers can be seen in these 12 files. Okay, so that's about how to use custom partitioner. So remember how to set the partitioner class. On configuration you have to set partition class and specify the partitioner, and these are where to specify the number of reduce tasks, right? So custom partitioners are useful when performing something called as secondary sort. We have a separate use case on how to perform secondary sort and what is secondary sort. We'll see later. Okay. So custom partitioners are also useful to avoid potential performance issues. What we can do is we can balance the output, the input going to each reducer by using appropriate partitioners. To avoid one reducer having to deal with many very large list of values, you can use custom partitioners such that the data will be evenly distributed among multiple reducers. Okay. For example, in our word count, we wouldn't want a single reducer dealing with all the 3-letter and 4-letter words, while other only had to handle 11 and 10-letter words. So assume that there are more 3 and 4-letter words. That means the reducer 3 and reducer 4 will have huge data, but whereas reducer 10 and reducer 11 will have less amount of data. So the data is not balanced among the reducers. So in such case we can write a custom partitioner to partition the outputs. Okay. So that's about custom partitioners. Hope you understood with examples clearly. If you have not understood, just go back to the same video, see it again, and you need to execute this lab. You have a lab documentation for implementing a partitioner. So here I have clearly given you the steps on how to implement your own partitioner. Please follow this documentation given here, okay, and execute this lab. See you in next video for next